So I'm Stavros Makrakis. I'm the product manager for the search aspect of OpenSearch, the open source project. Always hard to say OpenSearch and open source in the same sentence. And today I want to talk about something that all of you need. Some of you know that you need it, and only a few of you want it. So I'm going to try to convert that into, or we are trying to convert that into something that you will all want. So what's search quality? Here we are at a search conference. We sort of take search quality for granted. What is it? It's the foundation of search quality. So quality involves much more than just the relevance of answers. So the relevance is I ask for a canoe, I get a canoe. But if I'm selling canoes, I probably want to sell a canoe that I have a good margin on, one that's in stock, and so on. But you know, that's not what we're going to talk about today. We're just going to talk specifically about relevance, which is the foundation of all this. And relevant results, you may think that that's an old-fashioned concern in the day of AI and LLM and so on, but it's actually foundational. The quality of the result depends on the quality of the input, of the R in RAG in particular, the retrieval step. And I like to say garbage in, generated garbage out. If you give your LLM poor inputs, it's going to give you poor outputs. If you give your re-ranker poor inputs, it's going to give you poor outputs. So that's why I believe that relevance is the first problem you have to solve, and then everything else builds on top of that. Now, this is a standard slide that I show. I think this is like the third year I've shown this, or fourth year at Buzzwords. And because everyone seems to agree that it makes sense. And what it says is that if you want good search quality, there's a process to follow. And the process involves getting search results somehow. There are various mechanisms for getting search results, search processing we call it. Then there's measuring the quality of those results. And then there's tuning, so adjusting things so that you get a better result. I'm going to zoom in now on the measurement and analysis part of this. You notice the arrows are cleverly zoomed in. And think, what tools exist? What tools have been around in the intellectual marketplace to measure and analyze search quality? And the answer is, it's been something people have been working on for a while. You don't need to read all the details, but librarians were working on it in the 50s and 60s. They're saying, should we use card catalogs? Should we use subject headings? Should we use Dewey Decimal? What are we going to recommend to people? And you know, a whole series of research projects, mostly research projects, on tools for measurement and analysis. So one of the things that we have done with Eric's team and an OpenSearch team is start collecting the data you need, which is the first step of measurement and analysis, the data on user behavior. So User Behavior Insights was delivered last year in version 2.15. It's a tool for helping you collect the data about your users' behavior specifically designed for search quality. So most metrics tools out there don't collect the full information you need for search quality. And I won't go into more detail today. That was last year. Today we're going to be talking about the Search Relevance Workbench, which is a suite of tools to do online evaluation, offline evaluation, regression testing, and so on. And Eric's team has done a great job of putting that together into a nice unified tool. Part of that is because he's already made the mistakes.
Yep.
Eric, in fact, was one of the authors of a previous tool, an earlier tool called Cupid, which is still out there, still available, still perfectly valid solution. But every time you do implement something the second time, you benefit from what you learned from the first time. So let's think about the experience with past tools and what they're good for. Most of them have been developed for researchers. So here you are, you're a researcher, you have an idea for a clever way of doing whatever. You want to go from BM25 to BM35. Oops. You want a better version of BM25, or you want to tune BM25 or whatever. And so you want to publish a paper. Your goal is to publish a paper, not to produce better results for your users, at least not as a direct result. So there's a lot of tools for researchers. And what do researchers want? They want to publish papers, right, basically. Practitioners don't necessarily want to publish papers. In fact, practitioners want something a little bit different. They want to explore the data. They want to see what's going on. And one of the tools we have, for example, is what I call the eyeballing tool, which is specifically for exploring your data unlike many of the other tools whose main goal is to calculate metrics. Metrics are great. I have nothing against metrics. They're very useful, but they're not very good for understanding what went wrong. They're good for understanding that things went wrong, but not what went wrong. So practitioners, unlike researchers, want to do that kind of exploration. They also want the data management done for them. They do not want to have a complicated structure in Git of various data files and scripts and Jupyter notebooks and so on. That's not really what people want to spend their time on. At least that's our hypothesis. If you prefer doing things in Jupyter, good luck. So what is the Search Relevance Workshop? Workbench, I'm sorry, that's the second time I've made that typo. What is the Search Relevance Workbench? Well, first of all, it's practitioner-focused, unlike most of the tools out there for measuring relevance. It's about real data, not about benchmarks. So a lot of the other tools there are organized around standards like BEIR, where you have standard data sets. You want to compare different algorithms on standard data sets, which is a very valuable thing to do if you're building new algorithms. Less valuable if what you're trying to do is improve the results for your users on your data. Because getting results on biomedical research literature is very different from getting results on bathing suits. So we're focused on real data, not on benchmarks. We're focused on exploration, not just reports. So it's not about the output is a beautiful PDF or the output is a beautiful table in Excel or whatever. It's a GUI-based interface, so it's easy to use. It's within the OpenSearch UI. All the functionality is also available through APIs, so you're not stuck with just a UI. And we're open in various ways. So we're open in the sense that it's extensible to other search engines. So if you want to compare a result from search engine X versus search engine Y, they don't have to be OpenSearch. It's not at all tied to OpenSearch in that way. And it's open source, of course, so you can do whatever you like with it. What's inside it? Well, there are certain standard data types that we organize. I mentioned that data management is an important part of what we do. And there are things like query sets. What are the queries you care about? And various statistics about the query, like how frequent is the query? Where did this query come from? How did I collect this query? Was it out of user data? Where did it come from? Judgments, that is, people telling you how good a result is, whether it's by explicitly asking them, is this a good result? Rate this from 1 to 5 or whatever. Or if it's from user interactions, where you can calculate how relevant something is from the user behavior. It has the notion of an experiment, and very importantly, a concept that took us a while to focus in on and stabilize is the notion of search configurations. So in order to compare two things, you need to be able to talk about what is thing A and what is thing B. We learned this, what was it, in first grade or something with the cat in the hat. What is thing A and what is thing B? So thing A and thing B may be two different search engines. They may be the same search engine with different parameters set. They may be different corpora. There may be different things, all different things. Whatever they are, in effect, they're one thing you can test. So that's a really important core concept. So going from there, Eric's going to show you what we actually did. I'm just talking theory, and now we have reality.
Okay, all right. So search relevance, right? There's a lot that is potentially going on. There's a lot of features. And let's be honest, like I'm a search engineer, not a product manager or product designer. I'm more comfortable in back-end APIs, not in user experiences. So we thought about how could we approach building a tool that would be useful to people. And we know in the OpenSearch community, there are people who are just starting out on their relevancy journey, maybe have never even really thought about it, but maybe their boss called and said, this one query is giving terrible results, to, some of the most sophisticated teams at the other end who are doing these amazing things and maybe already have a lot of this tooling, and how could we draw them in and say, hey, we have something for you, right? And then people in the middle. So shout out to my colleague Daniel Wrigley for kind of coming up with these ideas. We came up with a couple of user journeys and thought about, for these different users, the freshman, the person who's just starting down the path, what can they use immediately to get some value? The traveler, the person who's been working with search for a little while, needs to have a more holistic view of search, wants to start really evaluating things in a more structured, repeatable manner. And then then, of course, our power users, what are the amazing things that we could be building and delivering out there. So we have 3 user journeys, and I'm going to live demo each one of those. So let's hope, starting with the freshmen, okay? And the crux of the freshmen is they have queries that they know they have problems with, and that's about it. They don't know why it's not working. They don't know how to fix it. Where can they get started? So, all right, so you're all familiar, or some of you may be familiar with the OpenSearch dashboards, OpenSearch UI, right? This is our search relevance workbench, and it drops you into a page where we can run experiments. We can do some things to start understanding search. So the data set that we're going to be using in this demo is the ESCI, Amazon's ESCI data set. Some of you may be familiar with it. Roman, are you here? Raise your hand. Awesome. Roman did an amazing job of connecting images to the data set. So we're showing products that actually have current images. Thank you so much. And I don't know if Matthias is in this room, but he did a great job of taking the structure of the ESCI data set and reformulating it into something that would work for what we were doing. So I'm going to show you a couple things. So I'm remodeling my bathroom right now, and I am at that point where I have to do drywall. And so I need some tools. I need tape and mudding tools, okay? You know, I want to, and I know that I don't have very good search results. So this is a tool that's been in OpenSearch since 2.x. It's a comparison tool. I am going to compare my algorithm on the left. And you can see I've got my little cheat sheet right there. Can everybody see? Do I need to make it bigger? We actually have a little more screen real estate right now. So are we good? Awesome. Thank you. Right. So we got a really basic algorithm right here. And someone says, hey, you know what might help it is, well, let's look and see what happens if we just boost on the title, right? You know, that always seems like a really good idea. Let's just boost on the title. And as you can see, we have this special syntax, this percent search text percent, and that's going to, you know, take our query and drop it in our template. Let's go ahead and do a search. Let's see what we got. Oop, thank you. There we go. We're searching the same index, 2 different algorithms, but it could be 2 totally different indexes that we're searching as well. So here we go. We've done a search. Now, this is a new feature at the bottom, this more interesting visualization. We have our algorithm on the left, result 1, and our algorithm on the right, result 2. And as you can see, there are 4 documents that are unique on the left, 4 on the right, and 6 that are shared. And we're seeing those documents right there and where they are in the position. Now, that's not very useful. Let's see if we can make that a little more useful for those. Okay, we're grabbing some data out of the document index. Now we have the IDs. Okay, here's our results, okay? So what happened here, right? Most of the results, 6 of them are common in both result sets, but 4 are unique. Well, that's interesting. Boosting on title, that didn't change our first 4 documents in positions 1, 2, 3, and 4, right? They're the same on both sides. But we lost, right, from position 5. What is this? Spline tool, screen tool. This is some tool for Windows screens, right? So that document fell out of our original list when we moved up. And then what happened in our improved algorithm on the right? Oh, Tape Buddy. Okay, that is a drywall tool right there, right? So arguably, we improved our search a little bit by getting rid of a non-relevant result on the left and adding it in here. Let's see what else. Oh, that's a little sad. We did lose this Tape Tech full set of drywall. That does seem like a pretty good result. But we also did get rid of an iPhone. I don't know why an iPhone cover was in there. Grip tape. Oh, we kept the grip tape. That moved up. And a generic toolbox, right? So we got rid of some not relevant results and then these other results in here, well, there's a drywall tape and mud dispenser. Perfect. And then not particularly great results, but they're at the bottom of the list. So this feels pretty good, right? I'm immediately able to start looking at queries and understanding the impact between two algorithms. And all I needed was a problem query. Okay, pretty happy with that. So, all right, so moving along. All right, this is great. I got one query. That's good. But I actually have a couple of things that got problematic queries. I actually have 3 queries that I'm struggling with. And so instead of evaluating things one by one, right, we've all done that. It kind of feels like a whack-a-mole kind of thing, like I fix one query and I break another. Let's actually see if we can understand a set of queries and how they compare with each other, okay? Each of these tools kind of has this little get started that tells you what you need. We need a query set. That is a grouping of queries. So let's go ahead and create one. Here we go. We got our list of queries. Problematic bathroom remodel queries. Searches with poor results, right? Something to remind me. Now, we have the ability of sampling queries from our production logs if we have that set up, but I'm actually only care about 3 queries. So I'm going to go ahead and grab them right here. There's my 3 queries. I'm going to type them in, right? Tape and mudding tools, Vermont American drill bit, right? Very brand-centric one. And then sliding window screens. So screens for a sliding window. There, I've got my queries. Let's go ahead and create that. Excellent. Okay. All right. Now we have our queries right here. Now, the other thing that we mentioned when we looked at the query set is we need a search configuration. This is kind of a new thing for OpenSearch. So a search configuration defines everything that you need to run a query. And so I am going to go ahead and I'm going to create 2 search configurations because I'm comparing one to the other for those queries. So let's go ahead and do baseline. Now you may remember this is what I did for the single query as well. So there's my baseline query. Oop, there we go. With my query substitution, I don't have a pipeline. Let's go ahead and make sure this works. So I'm going to search for hat. Make sure, yep. We're getting results back. Good. So I've typed it in. No problems. So go ahead and create that search configuration. And I have another configuration. This would be the one where I'm boosting on title. Okay. So I'll go ahead and create that. Baseline with title boost. All right. Same index. Same there. But you can see we have our boost. Okay. That all looks good. No pipeline. Let's look for iPhone just for fun. Validate. Yep, we are getting results back. Create that search. Okay. All right, let's go back. We have our query set. We have our 2 search configurations we can now evaluate. So we'll go in here. Problematic bathroom remodel. Let's go in here. Let's do the baseline first next to baseline with title boost. And we're going to look at 10 documents deep. We could look at 100 documents. We could look at 1,000 documents. We could look at 1 document. Kind of depends on what your use case is. And we ran the evaluation. Now, we're running 3 queries, so that took no time at all. It immediately completed. But if we were running 1,000 queries, they will run them in the background asynchronous. It takes a little bit. So let's go ahead and dig in and see what we have. Now we're starting to get some metrics, right? This is exciting. Now we're actually getting some numbers. In the first tool, it was purely qualitative. Does one look better than the other? Pure eyeballing. Now we're actually getting some metrics, okay? And the 2 metrics that we're shipping with are Jacquard and RBO, otherwise known as short for rank biased overlap. Jacquard is a great metric. It just tells you about churn between 2 sets of results. So on the left-hand side, we have 10 results. On the right-hand side, we have 10 results, of which 66% of them overlapped, okay? So we actually had a fair amount of churn. Is it good churn or bad churn? We don't know. right? We're just saying stuff did change. And sometimes you're like, I make a little change, so I expect very little churn. And if I saw a lot of churn, that would be something to me worrying. For what we're doing, it's okay. Our rank bias overlap in this example isn't particularly exciting as well. Rank bias overlap is the same as Jaccard, but it really cares about the overlap between the documents at the higher positions than at the lower, right? Under the idea that you don't really care what happens at the end of your result set, but you really do care what happens in positions 1, 2, and 3. So we've got some metrics that we calculated. Now, we can dig into the per query document metrics, right? Look at Jaccard. That's sort of an interesting one. Notice that this Vermont American drill bit, Jaccard of 1. That means there's no change. Both algorithms return the exact same results. But with the RBO metric, it says it kind of moves some things around within those sets. Let me see if I can show, not tell that. We'll go ahead and bring it back up. There's our title. Right? And as you can see, this is sort of interesting. You can see positions 1, 2, and 3, no change. Positions 9 and 10, no change. And the stuff in the middle all just change spots. But no new documents, no old documents. We could contrast this maybe with our, say, sliding windows, which has very low RBO and the most and some significant change. And as you can see, for this particular example, we had both the documents at the top in the original drop to the bottom and vice versa. Again, is this better or worse? That's not what it's telling us. It's just helping us explore and understand how things are moving in response to changes in our algorithm. Cool. Okay, great. And that is what you can do without anything else. Any person can come and try out those first two experiences. All right. So let's talk about this traveler, right? All right, so the traveler is now the person who's on their search relevance journey, right? They've already done some basic stuff. They have ways of gathering judgments, right? And a judgment is, and they want to start using them in the search relevance workbench. They want to systematically start evaluating the relevance, not just the churn like we showed in the other tool. So for these people, we have this search evaluation tool. All right, to do a search evaluation, right, we need 3 things. We, of course, need our query set. What are the queries that we want to evaluate? We need a search configuration, just one. We don't need 2 because we're just running 1 that demonstrates, what is the algorithm, what's the environment we're querying. And this new thing called a judgment list. And a judgment list is a rating of relevance for a query and a document. I'll show you an example in a minute. So we need these 3 things. So fortunately, we already have our query set. We've actually already defined our search configurations. That's nice. But we do need to add some judgments. And I'm going to go ahead and show you the one that we loaded, our ESCI data. It's a fairly large document. It's a big blob of JSON right now. But I'll just show you an example. So for this query, Tea Towels Kitchen, we're returning these documents, and you can see our ratings. So in the rating scale we're using, 100 means perfect, a 10 means related, a 1 means and then a 0 means irrelevant, right? You get to pick whatever rating scale you want, right? Some people like to do a 0 to 1, some like to do a 0, 1, 2, 3. Whatever rating scale you want to do, we support, but these are what these judgments look like. And we actually we're sourcing our judgments from this public data set, but we actually support 2 ways of I won't get into it in this demo, but we can actually create judgments out of using an LLM, right? Traditionally, judgments were created by human beings, but we can source them from an LLM. That'll be another day, talk for another day. Or using what's called implicit judgments, using the clicks, right? Stavros mentioned user behavior insights for gathering what people like and respond to. One of the ways we can use that data is to do implicit judgments, click-based judgments. So we have our judgments, we have our queries, baseline, and our configuration. So let's go ahead and run that evaluation. You can see it ran super quickly, only 3 queries. And now we're starting to get some of the classic metrics. NDCG, probably most of you have heard of that metric. It's a popular one for describing how well it's working. So for these 3 queries, we have a pretty good NDCG of 78. And we can kind of dig in here and look if we're interested. We can see, so for our tape and mudding, perfect. Okay, not good, perfect, and then we're missing some data. We have this metric over here, we called it coverage, which is of all the queries and documents being returned from the search engine, from OpenSearch in this case, how many do we have judgments? And for these 3 queries, we have 87% coverage. Now, the lower the coverage is, the less trust we can have in these numbers. 87 is not terrible, right? We can probably make some decisions on that. If it said 50%, then we'd say, oh, I don't know that these are so effective. Might need more judgments. So that wasn't bad. Well, let's go ahead and let's run a quick experiment with what we think is our improved search configuration baseline with Title Boost. There we go. We'll go run that. Great. All right. And it's going to be better. Uh-oh. Look at that. Our NDCG for our baseline with Title Boost actually went down. So while it appeared to work, and while it appeared to help things for that one query, the tape and mudding, overall, for those 3 queries, it was less useful. Now, we're kind of cherry picking here, right? Because we're looking at only 3 queries, and we're not looking at a representative query set. But fortunately, we do have a representative query set. So this is 150 queries sampled, where we make sure we get some head, some tail, some shoulder. We've done some good stuff to sample from our query logs. And, you can see this is our tape and mudding, our sliding, window screens. They're all there. Let's compare those 2 algorithms really quickly with a broader set of queries, a more representative query set. All right. So we've got, so we're going to use our ESCI queries, the 150. Let's go ahead and let's do a baseline just to see how baseline did. Our judgments, start our evaluation. Now you notice for the first time, it actually says processing, right? And that's because we generated the experiment, but now it takes a while, right? We're sending 150 queries off to OpenSearch, gathering the data, doing the analytics. It takes a little bit longer. So let's give it a moment. But we did finish pretty quickly. Now, notice here, over the 150 queries, our coverage went down. Honestly, we need more judgments, right? That would take it. And our NDCG score was only 0.35. Let's see if our baseline, with the Title Boost does any better, even though it didn't do great on those 3. So we'll go ahead. Come in here, baseline with Title Boost. I really thought Title Boost was going to work out. Okay, it's processing for a second. Let's give it a second. Come back. There, we finished. There we go. There it is right there. And hey, look, we actually did get a slight increment, right? The Title Boost, boosting on title by caret 25, did increment our NDCG by just a little bit. But if this is where we were starting from search, you might look at this and say, okay, we should push this to production because this is incrementally at least better than what our baseline is. Okay, so that is what we've got for the Traveler. This is all built into OpenSearch. All of this data is structured. It can be reused. All good stuff. But I talked about those power users out there, right? The people out there who have built their proprietary tooling and their pipelines and doing all of that. And what can we offer to them? Now, there's a lot coming in the next few months in the 3x line of OpenSearch, but I wanted to highlight two things that are there right now that may really appeal to some of the people who've already built their own infrastructure and maybe don't want to keep investing in their own infrastructure, because why are you building your own tooling when you're supposed to be delivering value to your users, not building tooling? So the first one is a story. So I hope all of you went and visit Superlinked, right? One of our sponsors. My colleague Matthias has been talking with Daniel about potentially, like, for us understanding better how Superlinked handles its embeddings and doing some innovations there, right? And so, you know, this was the conversation, sort of, between Daniel and Matthias. Hey, what data set should I use to evaluate e-commerce, and how can I share the results of the analysis? And I was very happy that Matthias was like, hey, I'll use the ESCI data set, right? We're already using it for other evaluations, and we can just dump this into the Search Relevance Workbench. All right, so what happened? Well, this is all Matthias had to do to put his data in. He ran his own evaluations in Superlinked with its own specific pipelines and things, and he did his own NDCG and things, and you know, he had his own tooling, but he spit it out in a standardized format, right? That's why data management is so important, so that we can have some standards. And he posted the data in, and hey, right, there's the experiment visualization that you already have seen, but none of this was run inside of, none of the data was in OpenSearch. We just used the Search Relevance Workbench. And then, hey, look at that, right? Our Superlinked embeddings beat out the lexical result handily, according to NDCG at 10, so that was really good. And yeah, there is the results from our baseline with Title Boost. And yeah, Matthias rolled me under the bus by highlighting that it was Eric's baseline with a Title Boost only did 0.37. So right here, we're able to start looking at evaluations and experiments in a structured way without sending spreadsheets and Python notebooks back and forth. And so the next step in this effort is, you know, we're looking at more evaluations of mixing up encoders, just using text encodings, and we can share those results right here inside of SRW. Okay. So really excited about this. First example of another search engine being integrated, and enhancing that more is coming in 3.2, 3.3 of OpenSearch. So the second thing that I'm really, really excited about about the work we've been doing with SRW has been, behold the power of dashboards, coming in OpenSearch 3.2. It'll be actually integrated and you'll be able to use it. But late last year, we did a lot of work on how could we surface evaluation metrics inside OpenSearch. So this screenshot is an OpenSearch dashboard that you can load yourself today. You'll have direct access in OpenSearch 3.2. And as you can see, this is maybe a lot more of the, this is a lot more of the deep dive that a data science or an analytics person is going to want to have on an evaluation, right? The metrics that I showed you a little earlier in the demo, they're a little bit the kiddie interface, right? We're kind of summarizing it up. We're trying to make it really simple. And so all of the different metrics that you might want, interesting, innovative query performance visualizations, looking at score density, drilling down into that per query, all of this leverages a lot of the power that OpenSearch Dashboards provides us to go that step beyond to do analytics, right? And so I can look in and really understand, where did the Superlink experiment work well, where did it not, and I've got those capabilities right there. But going beyond this, right, a lot of what we do in improving search is compare things. We want to know, these two algorithms, which one's performing better? And we also want to know, as things are changing in our environment, what else is changing? And so a little bit of a eye chart here, but this is an example of a dashboard where we're comparing 4 different algorithms, the Challenger, the baseline, and 2 research algorithms. And we're comparing them over time, how they're doing as data changes, as query sets change, right? So all of this is being driven off of what we're capturing in the search relevance workbench. So those are sort of 2 features that we think some of the maybe the more power users who maybe have their own infrastructure built might be really interested in adopting. And even if you're not an OpenSearch user, you may be interested in adopting OpenSearch's Search Relevance Workbench to do some of these analytics workloads and visualization workloads. So that's what we've got for you today, but there is so much more coming over the next few releases of 3.1. We feel like we kind of covered what the freshman needs. There's definitely some usability enhancements, some expanding, all of that, but you can start using this today without requiring anything fancier. For the traveler, we're working on scaling it up. For the first release, we put in a couple of limits, only 150 queries, for example, or 1,000 queries, right? But we're going to scale some of those up. Then for the power user, we'll be shipping those dashboards as part of the Search Relevance Workbench right there that you can use. So lastly, this has definitely been a journey, right, Stavros? We've been working on this for, what, 18 months, 2 years, something like that? We've been talking about it since a haystack 4 years ago, probably. So I just wanted to throw a quick shout out to all the people who've been contributing to this effort. It's been really awesome to get to work with such a great cross-section of people, some usual suspects and some new people. Yeah, so where do we go from here? So a couple of things. The demos that I just showed, those links, go ahead and grab your QR code so you can get to this slide deck and you can grab these links. How am I doing on time? Good. All right. The 2 links, the 2 demos I gave you, we've got runbooks right there where you can git clone the latest 3.1 and start using them. There is a nightly playground for OpenSearch that we are pushing this out in as we speak. You'll actually be able to play with that. What I showed you today, you can click that URL, go to Search Relevance, and start playing with it. It's going to ship in 3.1, right, Stavros? Really hope so, right? Because that's next. Yeah, so.
I've been on vacation for 3 weeks, so.
Yeah.
So, yes, of course, if you say so.
Yes. We all feel really good. So 3.1, OpenSearch has like this open of a release window close, and so it started last Tuesday, and it should ship officially sometime between now and next Tuesday. I'm kind of keep looking on Slack, waiting to see it announced.
Right. Keep in mind that there's a different release schedule for the open source version and the managed service version. So we're talking about the open source version.
Yep. And then, as you can see, we have 2 public repos on GitHub. Search Relevance is all the backend code, all the APIs. You can just play with it as a backend server-side tool, take a look-see at it. And then we have a dashboards project, which hosts all of the UI. We have a fairly active channel, #Search Relevance Workbench on OpenSearch Projects Slack. So you can go to opensearch.org/Slack to get the invite link, click it, come join us. We would love to get feedback, right? 3.1, we probably pushed maybe a little more in 3.1 than we might have wanted to, much to Daniel's stress, right? But we wanted to get a lot of stuff out there to get feedback, right? I didn't get a chance to show you the LLM as a judge, implicit judgments, hybrid optimizer. Like, there's a lot of stuff in there, but we're definitely looking for feedback. And so that's a great place to look at. Stavros, Daniel, myself, all here at the conference. We'd love to talk to you more. So, I don't know where we are on time.
So we have until when for questions?
Yes, maybe one.
In back?
Yeah.
Yeah, thank you for the presentation. Have you considered adding any performance metrics as well when comparing queries?
So, yeah, I mean, I think we'd love to. We'd love to. I've always wanted to get like a little spark line next to each query to sort of show, and even so there's a plugin for OpenSearch called the Query Insights plugin that lets you see what is taking time in a query. Wouldn't it be amazing to pull that structured data out and show it, just like in your Chrome debugger, right, where it shows you how long each web page is taking to render?
The short answer is the data is being collected, and it's just a matter of creating a join, essentially.
Yeah.
So yes, we definitely want to do that. It hasn't been our priority because we've been thinking about relevance in particular. But do we have time for another question?
Yes, maybe one quickly.
Thank you. Very interesting. So, do you plan to have you showed how you just paste the JSON containing the judgments. So
yep.
we suppose that you prepared that somewhere else.
Yeah, because we were using like this data set that Matthias hooked us up and Roman hooked us up with, right? That's what the raw structure looks like coming back out, right? But we do not have a human evaluation interface in it right now, right? Because that has its own challenges. Maybe there's other tools, Label Studio, etc. But we will, the other two ways of bringing that data in is we could configure LLM as a judge, right? We're all excited about offloading rating work to an LLM. So that's one option. And then if you've got those click logs and click data, then we can do it off of the implicit judgments and clicks over expected clicks. So are the other ways.
Okay. Okay. Thanks, everyone. So we maybe another question? A last one, because it's break time. So.
Yeah, thank you for the nice talk. I was wondering whether you thought about, so I would be really interested in, okay, I have configurations, and kind of batch generate them, right? So I say, hey, I want the boost in the range of there to there, over those and those fields, and I have a bit more flexibility there. And one last additional question, for the NDCG and stuff like that, do you consider allowing loading weights?
Yeah, I think that's the thing, is that if you really want to tie it to business value, you want to also look at, you build a richer definition of NDCG. And I feel like that's one of those practitioner versus researcher, right? I'm always like, we should take our NDCG score and then value in margin and availability and profit and all that. And everybody else is like, no, that's not what it's for, right? But it would help me solve my problem. So I think that we will see more scorers happen. We don't have the Cupid write your scorer in JavaScript and then we just run that type model yet, but there is a pluggable Java interface, so you could extend it that way.
So we talked earlier about wanting feedback. So we would like feedback on the existing system. We would like feedback like your suggestions, and we would love to have contributors. This is an open source project. If you have some specific business problem or idea, the code should be in condition to be contributed to.
Yeah.
If it's not, I'll get very upset.
It is.
But yeah, so we're happy to have contributors to the code and put in a PR if you have some contribution that makes sense. Obviously, you want to discuss it first with the team. But yeah, so we're delighted to collaborate with everyone.
Yeah. So, yeah.
Thank you. Great conclusion from Stavros. It's a call for contributors. It's a very interesting project. Thanks again, and it's a break time, 30-minute break. Thank you.
Thank you.